Polysulfides are a class of chemical compounds containing chains of sulfur atoms. There are two main classes of polysulfides: anions and organic polysulfides. Anions have the general formula S2-N. These anions are the conjugate bases of the hydrogen polysulfides H2SN. Organic polysulfides generally have the formulae RSNR, where R equals alkyl or aryl. Polysulfide salts and complexes. The alkali metal polysulfides arise by treatment of a solution of sulfide, e.g., sodium sulfide, with elemental sulfur S2- plus NSS2-, N+1. In some cases, these anions have been obtained as organic salts, which are soluble in organic solvents. The energy released in the reaction of sodium and elemental sulfur is the basis of battery technology. The sodium-sulfur battery and the lithium-sulfur battery require high temperatures to maintain liquid polysulfide and N+ conductive membranes that are unreactive towards sodium, sulfur and sodium sulfide. Polysulfides are ligands in coordination chemistry. Examples of transition metal polysulfide complexes include 2,2- and 2-. Main group elements also form polysulfides. Organic polysulfides. In commerce, the term polysulfide usually refers to a class of polymers with alternating chains of several sulfur atoms and hydrocarbons. They have the formula R2SX. In this formula, X indicates the number of sulfur atoms. Polysulfide polymers can be synthesized by condensation polymerization reactions between organic dihalides and alkali metal salts of polysulfide anions, and sodium sulfide plus NClCH2CH2Cl plus 2N sodium chloride dihalides used in this condensation polymerization. Dichloroalkanes form and 1,3-dichloropropane. The polymers are called thiocals. In some cases, polysulfide polymers can be formed by ring-opening polymerization reactions. Polysulfide polymers are also prepared by the addition of polysulfanes to alkenes. An idealized equation is 2RCH equals CH2 plus H2SX2SX. In reality, homogeneous samples of H2SX are difficult to prepare. Polysulfide polymers are insoluble in water, oils, and many other organic solvents. Because of the solvent resistance, these materials find use as sealants to fill the joints in pavement, automotive window glass, and aircraft structures. Polymers containing one or two sulfur atoms separated by hydrocarbon sequences are usually not classified polysulfides, e.g., polysulfide N. Polysulfides in vulcanized rubber. Many commercial elastomers contain polysulfides as cross-links. These cross-links interconnect neighboring polymer chains, thereby conferring rigidity. The degree of rigidity is related to the number of cross-links. Elastomers therefore have a characteristic ability to snap back to their original shape after being stretched or compressed. Because of this memory for their original cured shape, elastomers are commonly referred to as rubbers. The process of cross-linking the polymer chains in these polymers with sulfur is called vulcanization. The sulfur chains attach themselves to the allylic carbon atoms, which are adjacent to C=C linkages. Vulcanization is a step in the processing of several classes of rubbers, including polychloroprene, styrene butadiene, and polyisoprene, which is chemically similar to natural rubber. Charles Goodyear's discovery of vulcanization, involving the heating of polyisoprene with sulfur, was revolutionary because it converted a sticky and almost useless material into an elastomer which could be fabricated into useful products. Occurrence in gas giants. In addition to water and ammonia, the clouds in the atmospheres of the gas giant planets contain ammonium sulfides. A reddish-brownish clouds are attributed to polysulfides, arising from the exposing the ammonium sulfides to light. Properties. Polysulfides, as sulfides, can induce stress corrosion cracking in carbon steel and stainless steel.